recording. And today we are going to have a programming lecture. So the way I like to structure this class is usually on the Mondays it'll be our philosophy style non-programming lecture, and then on the Wednesdays it'll be a programming lecture. So that's half and half. All right, as good as we can do. So I'm going to talk to you about a programming language called Scratch today, which lives at a website called scratch.mit.edu if you'd like to go there. I will force you to go there eventually, but it's scratch.mit.edu. And then you'll click Start Creating, and it'll be pretty and fun. So I'll come back to this page, but that's where we're going to be for a lot of today. But before we get there, let me just go through some slides to get us ready to start programming if we've never programmed before. So I encourage you to follow along with what I do. I'm going to try and force you to anyway, but please follow along as much as you can, and shout out at me if anything stops making sense. It's my job to make it make sense. All right? So that's the one. We'll take us there again once we're ready for it, but we're not ready for Scratch quite yet. So let us begin. Let's talk about programming first, just in general. All right, so what in the world is a program? What in the world is an algorithm? That's another word that goes along with programming. So algorithms sounds like a fancy word. All it means is a sequence of steps to achieve some goal. It's a recipe for something. So if you have ever modified a recipe that you found online, you've been a programmer, technically. You've written an algorithm, all right? So a program is just a bunch of little algorithms jumbled together, I would say. Yeah. Oh, man. How long was it down? It's just going in and out? Is that what's happening? Oh, that's disgusting. Well, here's what we can do. I think there's a cable I can plug in. Let me go look for the cable. I don't know what's wrong. Sorry about that. When in doubt, I think the solution is to restart that thing. So I'm sorry about that. Let me stop or pause the recording. Continue the recording now. It looks like it's continuing. So hopefully the screen stays on now. So yeah, what is an algorithm? But just a sequence of steps. It's a recipe to do something. And so let's pretend that I got hit on the head. I have amnesia. Could anybody be a programmer for a second and tell me the algorithm to make a peanut butter and jelly sandwich? I have forgotten. Could someone please remind me? Who wants to be the first programmer in the class? Yeah? What are the steps? Ooh, I like that. Okay. Very nice. I like the specificity that you're using. I think you know where I'm going with this, but I think most of us just in our minds would say something like, oh, great, it turns off again. All right, what I'm going to do is I'm going to take this large computer's HDMI cable and plug it into my laptop. Oh. It knows. All right. I'll have the cable ready. Exactly. So most of us are probably thinking that our recipe in our mind is like, all right, just get some bread, put some peanut butter on the bread, put some jelly on the bread, you're done. You got peanut butter and jelly. But as a computer, I do want to tell you that that might not work out. So as a computer, if that were your recipe for me, I would follow those instructions exactly as you told me. So here, I would follow your algorithm, run your program to make peanut butter and jelly. You're like, all right, get some bread. Here is a bag of bread. There's a bag of bread. Yep. And they're like, all right, put some peanut butter on that. So here's the jar of peanut butter. I will put that on top of the bag of bread. And then you put the jelly on the bread too. Okay, here's the jelly jar. Put that on top of the bag of bread. And all right, I have finished running your program as a computer. Voila. That's peanut butter and jelly, right? That's what you wanted. Yeah?
Perfect.
Yeah.
You forgot to toast the bread, though.
Yeah, I should have maybe. We didn't say to take it out of the bag yet. Maybe put it in the oven. Take a flamethrower to the bag of bread. So that is essentially the best example that I can give you of how programming is different from real life. Okay, as a computer, you kind of have to talk down. When you're programming to a computer, you kind of have to talk down to it. You have to talk to it in a way that it can understand and in a way that you can specify exactly what you want. You have to think computationally, is the fancy term. Exactly. When you write a program, you got to think computationally, which involves using very small steps that the computer can understand, and you know exactly what it's going to do, and it's going to do it right. And then you also have to be very, very specific about what you want. So probably the correct program for at this level would be for a peanut butter and jelly sandwich would be like, all right, get the bag of bread, get a plate, put it on the table, reach into the bag of bread, take out 2 slices, put them in each of your hands, put them down on the plate, go get a knife, put the knife in your dominant hand, open up the peanut butter jar, stick the knife into the peanut butter jar, spread some peanut butter onto one of the sides of bread, do the same for the jelly, right? And then put together the 2 slices of bread so that the peanut butter and the jelly are touching, because you could do it the other way too, right? It's very, very specific that you have to be. And that's kind of at the level that you have to talk to your computer. Okay, it's going to be very tedious as you're starting out, but hopefully this example tells you the reason why, because you need to tell exactly what to do, because it's not assuming anything. All right, so I hope that makes enough sense. So that's programming, that's algorithms, and today I'm going to teach you a brand new language called Scratch. I don't assume you've ever seen it before. I don't assume you've ever programmed before. And it's a graphical programming language. It's meant to be people's first programming language, so it's really cool. You just drag and drop these little block things, so it's like Legos, and they look like this, and they fit into each other very nicely. And so like you add this little block, and you put this other block below it, and then they just all fit perfectly together. It's really cute. And the whole idea is each block does a single thing. Right? They're all different operations. Like this is operation 1, this is operation 2, this is operation 3. And what happens when you run this program, all right, when you run this program, it's going to go through all these blocks and do all those operations in order from top to bottom. Okay? Order is key as well. So this is what happens when you run the program. It's going to run all these blocks in order. Another word for run is execute. It's not like it doesn't mean that the computer is murdering your program. It just means it's another word for run. So I'll say that as well. Execute in order. That's what's going to go on. And that's just another word for run. So that's what's going to happen when you drag all these blocks out. You start the program. It's going to do this one first, then this one in order because they're linked together from top to bottom. Okay? That's how Scratch is going to work. And now we're ready to go there. So let's go to scratch.mit.edu if you're not there already. All right. Well, let us go there. You probably also just search Google for Scratch. This will be the first link. But once you go there, let's just go back out so I can show you. You go to scratch.mit.edu and you click Start Creating. And that opens up a brand new blank program for you. And you're off to the races. So this guy right here, let me try and explain. On the left side are all the blocks that you can drag out. Right? That's your toolbox. There's a lot of different sections. Feel free to look through them all. The middle section is your code. That's where the program that you write will be. That's where you're dragging the blocks out onto. And then the final side over here is where your program will run. It's going to do stuff to this little cat as well as other things that we're going to drag out. So it's going to like make animations happen. It'll be super cute and fun. This guy is called the Scratch Cat. He has his own Wikipedia page. It's very fun. There's a lot of lore associated with the Scratch Cat because everybody learns Scratch and makes up stories about this dude. So you can use any pronoun with the Scratch Cat. It's non-binary. And he has so many things on his Wikipedia page. So yeah, feel free to look into that. But that's the Scratch Cat, and he's the default in every program. You can get rid of him, but he's always there for fun. All right, and so I guess, let's see. All of these things are going to mess with the Scratch Cat, and I guess I'll get into them as we go. But the very first thing that I want to do, the very first program that I want to write for you is, they would take my computer science card away if I didn't do this, customarily, when you learn a programming language, a brand new one for the first time, you're supposed to write a program called Hello World, which it's a very simple one. It runs and it just prints out to you the words Hello World, like you've just created life or something, and you've told the computer what to do and it's following your instructions, something like that. So it's customary to write a Hello World program first, and so that's what we're going to do. So let's find a block that will let us say stuff and print out stuff to the screen. So it's all in terms of the Scratch Cat. This is his program right now. So does anybody see a block that looks like it might say words, speak, something like that? Yeah, that's in the looks section, the purple section. So you can either say hello. There's also a think. That's probably like ... bubbles. This is like say is more of a speech bubble. But you have this, and I'll zoom in here so you can see it bigger. This says something for a certain number of seconds. That's a block that does that. All right. This one just says something, and the idea is it's never going to go away until you say something else. So I like the ones that go away. That's easier, I think, to think about. So this says hello for 2 seconds. It's almost the right program. And to run it, you just click the block. Click. There's the Scratch Cat saying hello. And so I want to modify this, of course, to say hello, comma, space, world, exclamation point. And now when I click the block, he says it for 2 seconds and it goes away. Of course, you can change the number here, like you want him to speak fast for 1 second, 3 seconds. It's fine. Whatever you feel like. With that, that's our first program. So it's only a block, but we're getting there. Okay? Any questions about this so far? Does it make enough sense? So, not yet. Right now you have to just click the block. Did you add this? Okay, yeah, maybe click it again. So that is Hello World. Interesting, right? And of course you can chain these together, like you can say like bye or something, like that's the end of the program. But you can link them up, and now when I click any of them, it's just going to run the whole thing. This is now a big program. It's made of 2 things. So it says Hello World for 2 seconds, then it says bye for 2 seconds. See how it's going in order like that? If you're done with something, you can right-click, delete block, or you can just drag it back to the left. So it's kind of ugly to just click the block to start the program. Normally, you click the green flag and the program starts. So let's do that. Let's make it so that the program starts when we click the green flag. That's the normal way of doing this. So here are some terms. So in Scratch, it takes what's called an event to start our program. Really, we've been cheating by clicking the block. So really, there should be some event that starts our program. And we'd rather click the green flag to start the program. And so there are a bunch of events that can start something off. The simplest one is just when the green flag gets clicked, do everything below it. And do you see how, like this block, you can have things above and below it because it's part of a normal program, but event blocks, they look a little funky because you can't have anything above them. They start computations. They're not in the middle of something. They begin things. You can't have blocks above them. But they link together like that. So when the green flag gets clicked, if I click over here now, it's going to run everything under that event. You see that? That's the goal. They're going to start that computation. And now when I click the green flag, it says hello world for 2 seconds. It runs every block below for 2 seconds. We just have one right now. Okay? And so I click it. It's done. If you want to stop it midway, you can click the red button as well, the stop sign. But that's our program. When the green flag gets clicked, that's an event. That starts, goes here, looks here, and it starts running all the code down below that flag. Okay? That's an event. Another important thing that you're going to want to know as a computer scientist is, like, this is code. We can save this program and come back later, and maybe, like, once your programs get long enough, you're going to come back and forget what you were doing. So a lot of the time, a good idea is to write what's called a comment next to some of your blocks. Those are just little sticky notes for you, the programmer. It's not part of the code. It's not going to get executed, not going to be run. Just for you to remind yourself what you were doing. Just leave yourself some notes for any reason. To add a comment next to a block, you right-click on that block and click Add Comment, and it leaves you a little sticky note. It's like this. This is kind of obvious what this is going to do, but usually you'd say something like what your program's about to do or what this block is trying to do. It says Hello World for 2 seconds. And you can resize this, move it around, but that's the point of a comment, to just leave yourself a note. It's not part of the code, though. Just over there to the side. So yeah, that's our first program. Yay, we did it. Pat yourself on the back. So I will give you these programs that I write. This one's very simple, but I'll give you all of them. If you ever want to save your own programs and load them back later, you go to the File menu, Save to your computer. And then it just downloads it with some default name. You don't have to. I'm going to download mine so that I can give them to you. There you go. So that's our first program. Let's make it more complicated now, because there's much cooler things that you can do in Scratch, and I want to show them to you. A main thing is animation. So let's make a silly little program that has the Scratch Cat like getting a banana out of the fridge and like walking away with it. Something fun like that. And so we have some more terminology. So Scratch Cat is a sprite, we say. It's just a person or a picture that can move around on the screen. So he's a sprite. He has a name. By default, he's sprite1. Let me actually go to File, New to just delete everything and start from scratch. So yeah, at the beginning, you have sprite1. You have nothing over here. We can rename him to Scratch Cat. Whatever you want. Give him a real name. And then also notice how if you click and move him around, some things are changing. There's a coordinate system. See him right here? Like 0, 0 is in the middle of the screen. This is like positive in both directions, negative in both directions. So there's secretly like a coordinate system going on the screen, something like that. And so like 0, 0 is in the very middle. But this is Scratch Cat. He is a sprite, and we can do things with him. And you can have more sprites on the screen, is the next thing that I'm trying to say. You can go to this little picture of a cat and click the Choose a Sprite button. And we're going to add some bananas, because the bananas are going to walk with the cat. So here's the bananas. I'll click on them. And so now there's 2 sprites. 2 sprites in my program. Bananas and Scratch Cat. All right. I click this button down here, Choose a Sprite. And then you can drag any sprite out. I'm dragging you can click any sprite. I'm clicking the bananas. And then also, each of these sprites can have a program associated with them. Like the Scratch Cat can have his own program when the green flag gets clicked. The bananas can have their own program when the green flag gets clicked. We're going to do that in a second, but that's important. You can have pieces of your program that are just decorations, and those are called backdrops. So that's in this other section down here. So not choose a sprite, but choose a backdrop. If you click that, you have many, many options, one of which I think is a kitchen. And so I'm going to find that. You can search for it, but I don't remember where it is. Fridge. There's a refrigerator block. There we go. Nice. Backdrop. So here is the refrigerator. Here's the Scratch Cat. Maybe the bananas can start out in the fridge, and he can like walk to them. But that's going to be kind of the start of the program, right? So here is my algorithm now to make this program happen. I want to just make a little animation of the Scratch Cat walking to the fridge, grabbing the bananas, walking away. Okay, so we're going to want to start the bananas out in the fridge, start the Scratch Cat over here, and then when the green flag gets clicked, I want to like move the Scratch Cat over to the bananas, and then have him walk away with the bananas. Okay, and so there are a lot of do this because we want his program to start when the green flag gets clicked. But there's a lot of things that we could do with him, one of which is moving him. So there's the motion section, all right? There's a lot of things. There's the moves 10 steps block, which just moves them in his current direction a bunch of times. There's also a direction for the Scratch Cat, like it's down here, he's set to 90, but you can move him around, make a different initial direction for him. You can also change his size, like it could be 200% size, giant Scratch Cat, 100% size, and you can either show or hide the Scratch Cat. We just want him always shown for this program. So yeah, move 10 steps. That's walking away from the fridge, so maybe that's not the best one. I think the best block is the glide block. Glide, and take 1 second to glide to this particular coordinate. You see that? And where do we want the Scratch Cat to go? Like we want him to go next to the bananas, like right here, and watch his coordinates change as I move him. So like if I want him to end up here, that's coordinate -164, -95. I can do that. And then now if he's over here, and I click the green flag, he's going to glide, take 1 second to do it, over to that coordinate. You see that? We move him away, bring him back. And maybe he's hungry, so he's lethargic. We can make him take 2 seconds to glide over. How about that? All right. Any questions about the glide block? It's a lot easier to notice, though, and not like have to type the coordinates. Notice how when I move the scratch cat, these go-to blocks are changing to whatever the current coordinate is. So just like get him where you want him to be, and then the coordinate's already set for you. That's kind of cool. Glide 2 seconds to that coordinate. Okay? Does that make enough sense? And then we want him to walk away. Yeah. Go to, like, teleports him. That's like, okay, if you're over here, go to, it's like, bam, you're right there now. That's immediately go there. Glide is take some time as you're doing it. Go everywhere in between, too. Yeah. So hopefully this is fun for you guys. So that is the glide block. So he's going to walk to the fridge, and then hopefully he's going to grab the bananas and then walk away. But right now we're working on the Scratch Cats program. So if we want him to walk away, like end up here, I'll just have another glide block after that. Take another 2 seconds to glide to that coordinate, whatever it's this one, 178, negative 103. Pick whatever one you want. But now when I run the program, it's going to walk over and walk back. Isn't that fun? Walk over, walk back. Cool. All right, so that's that. It's running all those things in order. And this program, notice how the Scratch Cat is highlighted down here in the bottom. This is a program for the Scratch Cat right now. This is why the gliding is only working on that sprite, on the Scratch Cat sprite. If we want to move the bananas, we need to go and make a banana program. So if we click on the bananas, notice that there's nothing there. It's blank for that banana program. There's nothing there yet. So let's give it a program. Let's have something happen when the green flag gets clicked for the bananas. They're supposed to walk away with the Scratch Cat. So they're supposed to, like, I don't know, move over here and end up here with him. So, like, take 2 seconds to glide to that location. Yeah? Take 2 seconds to glide to this. And so now, putting the bananas back in the fridge, when the green flag gets clicked, both this program will run, the gliding of the Scratch Cat, and this program will work, the gliding of the bananas. There is an issue right now. Does anybody see it? What will happen if I click the green flag? Is it going to do the right thing? No, it'll walk away without bananas. Yeah, so let me try this. Because the Scratch Cat's got to go over here first and then walk away. How much time is he taking to do that? 4 seconds total. Bananas are immediately gliding away, so watch. Whee! They're passing him. That's no fun. So what should have happened to the bananas? When should they have glided away? After the Scratch Cat got to them, right? He's supposed to be walking with them. So what does that mean? The bananas better wait. The bananas better wait 2 seconds, because that's how long it takes for the Scratch Cat to get to them. It won't look like he's with them unless they start moving only after 2 seconds. Does that make sense? Because then the Scratch Cat's going to be touching them, ready to move with them. Right? It's a separate program, but we want it to look like he's holding them. Okay? And so there is a wait somewhere. Is it control? Yeah, it's control. So these bananas better wait 2 seconds, because that's how long it's going to take for the Scratch Cat to get over there. And then when you save and you load this again, you're going to wonder why did I put a wait block here? So that's why we have comments. Let's leave a comment for ourselves saying it takes 2 seconds for the Scratch Cat to get to the bananas. And then you'll understand, like, okay, I understand why I put the wait block now. It should stay. So now, when the program's run, it's going to do the gliding, and then the bananas are going to wait 2 seconds. They're still, and then after that, they're going to glide away with the Scratch Cat. Isn't that cute? So that's the goal. All right. So that's that. Let's see here. Yeah, so we're just moving the banana to the same place that the Scratch Cat is going. and the banana's going to take just as long to get there because we want it to look like he's walking with them. So we shouldn't have made the bananas like take 1 second to glide, take the full 2 seconds because they need to walk with the scratch cat. Okay? There's another problem. Does anybody see it? If I click the green flag now, is it going to do the right thing? Can you run the programs in your mind yet? Watch. Scratch cat walks over, walks away. The bananas didn't go anywhere. Why? It's waiting 2 seconds and then gliding to that location. This is a bananas program, but they're not moving. What happened? It says glide 2 seconds to this location. Bananas are already at that location. You see that? So it's going to take 2 seconds to do nothing. What should we have done when the program starts? Yeah, teleport the bananas to the beginning, back to the fridge, because that's where they should always start their life, right? We don't have to glide them there. They should just teleport. Immediately go to the fridge, please, bananas. And so that could be the go-to block. Go-to just immediately takes something somewhere. Please go to that location, wherever that is. Start your life there, bananas. That'll make sure they start in the fridge. So again, we can add a comment. It's like, make sure the bananas start in the fridge. Does that make sense? So again, scratch cat's going to glide over, glide back, take 4 seconds, and now the bananas will always start right there, wait 2 seconds for the scratch cat to catch up, and then they'll glide back with them. And now if I run the program again, the bananas teleport to the fridge to the right spot. Okay? All right, there is secretly still one last issue with this program. Does anybody have any thoughts? It is working, though, every time I click the green flag. It's a very subtle issue. It would only happen if I messed something up, or if I stopped the program early. Let me do that. Boop. Or even, better yet, somewhere like that. So, if I click the green flag now, the scratch cat, what's his job? You just glide 2 seconds to the fridge, glide 2 seconds back. He's a lot closer to the fridge right now. See that? If I stop the program somewhere, the scratch cat does not start on the right. So if I want him to look like he's coming from far away, he should start his life here, away from the fridge, just like the bananas started their life in the fridge. Does that make sense? It would be always the same animation if we did that. So please, scratch cat, start your life at this coordinate. And then no matter what, if I stop the program early, the bananas are going to teleport to the fridge because we have the go to XY, and then the scratch cat's going to teleport to way over to the side of the fridge, and it's always going to be the same animation from there on out. Okay? Any questions about any of that? So that's our first more complicated program. Do these things in order. When the green flag gets clicked, the scratch cat does all this, goes to this location, away from the fridge, glides into the fridge, and then glides away. That's his program. That's what he's doing. And then the bananas, to make it seem like they're being taken away by the scratch cat, they have to teleport into the fridge because we want to make sure this all starts over again when we rerun the program. They wait 2 seconds for the scratch cat to get over there, and then they take the 2 seconds to go to the same spot that the scratch cat is going. So it looks like he's walking with him. Okay? So that... Can you say that louder? The code for the cat? Yeah, here it is. And again, your coordinates don't have to be exactly the same, just thereabouts. Just get them to where you want them and then drag out your go-to block or your glide block. It'll all change to that. Okay? Any last questions about any of this before I give you a more complicated example, even more than this? Oh, you brought a bird out? Okay, yeah, I can help you a little bit later. Let me finish this this next example, and I can help you get your bird working. Because then I'll give you your next programming assignment, and I'll also let you guys do a question. So that'll be the perfect time to answer that. Okay? So just sit tight for a little bit. So I just saved that. So I'll give that to you as well, this program. And then I'm going to start from scratch again. Brand new. All right. Here's my last most complicated example for the day. Let's have an alien abduction program. So let's make an animation where the Scratch Cat is getting beamed up into a flying spaceship by aliens, and he disappears, and the spaceship flies off. All right? That's the most complicated thing I think I could think of, and the most interesting thing I can think of. So let's make that happen. And by the way, that idea of starting out the bananas in the fridge and the Scratch Cat away from the fridge, there's a word for that. It's called initialization. What do we want to happen at the start? So we initialize the Scratch Cat to start away from the fridge. We initialize the bananas to start inside the fridge. Okay? That's the word that we really wanted to use there. Okay? So here's my algorithm for the alien abduction program. We're going to have a UFO, like a little flying saucer, appear. And so there's going to be a concept of like it was invisible before. There's going to be this show and hide kind of blocky stuff going on. There's a block that controls this. So the spaceship's going to be invisible. It will make itself visible. It'll glide down closer to the ground where the Scratch Cat is. It's going to send out a little tractor beam. And then the Scratch Cat will glide up into that beam. And then the beam will get shut off and the cat will go away as well. It's like he went inside the spaceship. And then the UFO is going to fly away. So that's the idea. There's going to be like a UFO sprite, a beam sprite, a Scratch Cat sprite, and then like a cornfield backdrop, something like that. But all these different sprites are going to be interacting with each other. Or we're going to have to time it so that it looks like they're interacting with each other. Okay? So that's the goal. So let's find a nice backdrop. I think there's supposed to be like a farm backdrop. What else is there's a hayfield backdrop. That has to be the one we use, right? So here's the Scratch Cat. We could even make him small, like zoomed out, size 50 Scratch Cat, size 75 Scratch. It doesn't really matter. So here he is among the hay bales. We can give him the name Scratch Cat again. He deserves the name. And then what else do we need in this program? We need a UFO. I think there's like a little spaceship or something. UFO, spaceship, or like ship. Oh, let's use the rocket ship. That's fine. This can be, pretend that's a UFO. And so it needs to go up there. What else? We need a beam that's going to like take the Scratch Cat away. And there's no beam sprite, but there's a really cool thing that you can do in Scratch. You can design your own sprite. So instead of clicking choose a sprite, you can go up to the little paintbrush and you can make your own. So let's make a little beam for the Scratch Cat. I guess it's going to look like a little, what's it called? I forget what the shape is. Trapezoid? Is that what that is? And then you can fill it with something and it can look like that. This can be the beam. Obviously, it should be like see-through. There's a way to make it see-through. Dun, dun, dun. That was the paint a sprite. Not choose a sprite, but paint a sprite. And so I filled in this little guy. I'll make it again one more time, but again, you can paint with the paintbrush if it's not working for you. So I went to the line. It's not a big deal, whatever you choose to make your beam as, but I'm going to draw a bunch of lines, and then I use the little fill tool to fill it with the default color of apparently purple. And so that made a sprite for me. And now if I go back, this was the costumes tab, I can go back to the code tab. I can move this sprite around, and I want it to be invisible. There is a looks section of the code where you can make it kind of invisible. It's the not change the color effect, or set the color effect, but there are different effects that you can change. We can change the ghost effect that has to do with transparency. So if we set the ghost effect to like 0, that means it's 0% transparent. If we want it to be 50% transparent, we can run this block that makes it 50% transparent, something like that. So that looks more like a beam, I guess. It's going to take somebody away. So those are my 3 sprites, and I can call this beam, by the way, and give it a name. So these are my 3 sprites that are going to play along with each other. and I think I'm ready. So each of these are going to have a part to play, yeah? And so they're going to do something when the green flag gets clicked. The beam is always going to be transparent, so we can have that be its first thing, but we also want to make it invisible at the beginning. We'll get to that. But they're all going to have their own little program when the green flag gets clicked. The scratch cat, the rocket ship, the beam. And so initialization is key because the scratch cat's going to get beamed away. He's going to become invisible. There's a lot going on there. So the scratch cat should always start his life down here. Let's pick that spot for him. And so this is the scratch cat's program. Get him in a good spot and just make sure he teleports there at the beginning of the program. We want to initialize him. What next? And so at the beginning of the program, the UFO should appear. And so at the very start, let's see, we should keep the rocket ship hidden. I'm going to start off the rocket ship hidden. You see that? I click the hide button down there. So the rocket ship is hidden. The first thing that it should do when the green flag gets clicked is show itself. All right? And that's probably in the looks section. There's a show block and there's a hide block. So we want the rocket ship to show itself as the green flag gets clicked. And then it needs to move down closer to the ground. So it shows itself, then it glides down closer to the ground. The beam is also initially hidden. Maybe I can do that now. The rocket ship is going to glide down. Here's good. So after it shows itself, it will, we're also going to need to initialize it, but we'll deal with that in a second. It should glide down maybe here to the scratch cat. That looks like a good spot. Let's have it take a second to do that. So glide 1 second to that exact spot, and then it needs to send out its beam. So at the beginning, I want to have the rocket ship up here. It should be hidden, and now when I click the green flag, it should show itself and glide down. Whee! Something like that. And then it's going to send out the beam, but that's the beam's program's job, not the rocket ship's program's job. But that's the idea. Now when I click the green flag again, notice how it doesn't do anything, because glide, show yourself, well, you're already shown. Glide to this place, you're already there, right? So the rocket ship should start its life maybe up here somewhere. Let's teleport it up there. Let's initialize the rocket ship. Is that making sense? Me using those words. So now, show yourself, glide down. Or teleport here, show yourself, glide down. Whee! And if it was hidden, as it should eventually be, it's going to look like that. Eventually it'll hide itself at the end of the program. Whee! Any questions about that so far? So that's like the rocket ship's job. And now the beam needs to get sent out from the rocket ship. Yeah, let's line that up right. So the beam needs to show itself. This looks like a good part for the beam to be in. So maybe it can live here. Can make sure it's in that spot. The beam is going to start out hidden, so it should show itself. That's in looks, right? So make sure you're transparent, show yourself, and then go here. Does that make sense? Whee! But if I rerun it, and I make sure to hide it before, this is the beam's program, by the way. It's already showing itself before the rocket ship gets in place. So what should I be doing instead? What am I forgetting? We want to have that beam only show itself once the rocket is in position. So it's showing itself too early. What should it do? What's the block I used for the other program to make the bananas stay in the fridge? What did I say that I did? Dun, dun, dun. Have the bananas wait. Is that coming back to us? Is it too late in the day to remember these things? All right. So the beam needs to wait for the rocket ship to get in position. How many seconds does it take the rocket ship to get in position? This is the rocket ship's program. How many seconds does the beam need to wait before showing itself? That's a good thought. Like you're thinking like this is going to take some time, the show's going to take some time, the glide's going to take some time. Yeah. The secret though is any block that does not have a seconds associated with it, it happens instantaneously. So these two blocks, they happen in the blink of an eye, they don't take up any time at all. So technically, this whole program takes 1 second to run. Does that make sense? It's only really going to take 1 second. This one's going to be instantaneous. Go to show is going to be instantaneous. And the glide's going to take 1 second. And so after 1 second, that's when the beam should show itself. Does that make sense? That's the goal. And so wait 1 second, beam, before showing yourself. This is the wrong order right now. I did it wrong. Wait 1 second and then show yourself. The other way would have been the wrong order, right? Because this, add comment, the rocket ship takes one second to glide down, right? And so if I hide the beam, watch the rocket ship come down, see how it's working now. It's playing nicely because it's waiting that 1 second for the rocket ship to get into position before showing itself. See that? That's the goal. And then, say that again, I can't hear you. It takes 1 second to glide down, because that is, I used a glide 1 second block. Every other block takes no time at all to run. They take like nanoseconds to run, so we don't count that. So that is a good start. Maybe a good initialization in case you stop it early and the beam is shown. Like, you want to make sure that the beam, when you start the program, should be hidden. So let's just make sure that like it's transparent and it's also hidden at the start of the program. So like we can hide it too. Why not? That's working. It's working a little bit better. So this is the beams program. Make sure you're hidden. Make sure you're transparent. Wait a second for the rocket ship to come down and then show yourself in the right position. The beam's never going to move, but I guess the go-to is fine. It's useful. I guess that's more of initialization anyway. Like here, it could be up here. Yay. Are there any questions about these programs so far? So the Scratch Cat's doing nothing. He's starting in a certain spot. The rocket ship is starting up high, showing itself and if it's hidden, and then gliding down. Whee. And then the beam is starting out hidden in a certain spot and transparent. Those are the first 3 blocks. And then it's waiting a second for the rocket ship to get into place before it shows itself. Okay, do you see how those are all happening in order? It's very key. I don't think there is, just like we would want to do with the bananas. You could technically make a new sprite that's both of them and hide the original ones and show only that one. That's a possibility, but that's all I can really think of. You can make a brand new sprite that you just draw both of them at the same time, but otherwise you just got to move them at the same time. Yeah, good question. There might be a secret. I do not know that secret. Any others? All right, so what's the rest that we got to do? So after the beam gets sent out, the cat needs to glide up. So the cat needs to start gliding once the beam gets sent out. How long does it take for the beam to get sent out? Now, when should the cat start gliding? How long should it wait before it starts gliding? So this is the beams program. How long does it take for the beam to show itself? Every block that doesn't have seconds associated with it happens instantaneously. So what does that mean? How long does it take for the beam to show itself? 1. Good. It only takes 1 second for the beam to show itself. The rest of these happen immediately. And that's how long the Scratch Cat should wait before he gets beamed up. So wait 1 second. This is the Scratch Cat's program. So wait 1 second for the beam to get sent out. And then it's the Scratch Cat's turn to get beamed up. I gotta move this beam out of the way so I can get the Scratch Cat into the right spot. Like we wanted it to glide up to here or something. Yeah, glide up into here, close to the rocket ship. And so that could be a glide block. Glide 1 second to that location. Maybe it's a slow, not a very powerful beam, so it takes him 2 seconds to get up there, something like that. And I'll put the beam in the right spot again. So this is the Scratch Cat's program. Rocket comes down, Scratch Cat waits a second to get beamed up. Cool. And because of this initialization, he's always going to start on the ground. Whee! gets beamed up. Beautiful. It takes 2 seconds doing that. So, all right, we're almost there. So after that, after the cat is beamed upwards, the beam and the cat should like go away, right? They like, he's in the ship now. The beam's gone, the cat's gone. So they should both hide themselves, okay? And that is looks again. So after you glide, cat, hide yourself. Whee! So now he's hidden. And now if I rerun the program, there's a problem. Where is the cat? Where did he go? I hid him, but I never showed him, right? We want him to start out shown in case he's hidden. So that is another initialization problem. So show yourself at the beginning, cat. Does that make sense? That's what we got to think about as programmers. So now he's always going to be shown at the start because we initialized him down there and shown. So really the last few pieces of the puzzle is the cat hides, yes. The beam should also hide at the same time. The beam should hide at the exact same time. And, okay, the question now is, how long should the beam wait before it hides itself? Because if I just say show hide, those are both going to happen instantaneously. It's like the beam has only been hidden. We're not going to see it shown. So there needs to be a waiting in between here. And my question is, how long should the beam stay shown? Here's the Scratch Cats program. What are our thoughts? How long should the beam stay up? What does that correspond to? It's like how long the Scratch Cat gets taken. How long the Scratch Cat takes to get beamed up. So I guess that's the real question. How long does that take? This is a bit more of a trick question because I have a bunch of blocks here now on the Scratch Cat that have seconds, but you can't just add them up anymore. Because this initial waiting was for the beam, was before the beam got sent out, right? Wait 1 second for the beam, and then you glide, yeah? So how long should the beam stay shown? How long does it take for the Scratch Cat to go up there? Which block was that? Take a few seconds to think about it, at least in your brain. If you're too shy to say the answer, at least think of something. And then I'll move on in a few seconds, but I want you to try. I want that beam to go away once the Scratch Cat is up in there. And this is the Scratch Cat's program. How long has it taken him to get beamed up?
2 seconds.
Good. Yeah. So it waited 1 second. The beam has not been shown so far. The Scratch Cat's waiting a second for the beam to get shown. And then it's taken him 2 seconds to glide up into the beam. After that, the beam has done its work. It's taken the Scratch Cat up into the ship. Yeah. So it's 2 seconds. It's just this block. That's the gliding time for the beam. So, or for the cat. And so, the beam should stay shown for 2 seconds. That's how long it takes for him to glide up into the ship. And then the beam can hide itself. Does that make sense? That's important. And it takes 2 seconds for the Scratch Cat to glide up. Because we used a glide 2 seconds block. Yeah? And then it can show it. Then it can hide itself. So this is the beams program now. Whee! And then up it goes. And that's almost the whole program. All that I want to do now is have the UFO fly away. Have the rocket ship fly away. So after all that's happened, have the rocket ship fly away. And so now the question is, how long should the rocket ship stay right here before it glides off? See, there's more waiting, because he can't just make him immediately go away. He's got to wait for the cat to be beamed up. How long does that take again? That was 2 seconds. That's how long it takes for the beam to do its thing. And so the rocket ship should stay right here for 2 seconds, because that's how long it takes for the Scratch Cat and the beam to show themselves, get moved up, and then hide themselves. 2 seconds. Does that make sense still? 2 seconds to do that, 2 seconds to do that. Then they're both hidden, and then the rocket ship can go away. So it can glide off back up here, I guess. And we can do one last block here. I like 2, can take 2 seconds, why not? But it needs to wait. It can't just immediately do this, because watch. It's like, it's going off. We want it to stay there. We gotta wait. Wait in between these 2 glide blocks. And it's the 2 seconds that it takes for the cat to get beamed up. So I think now I got the right answer. This is the rocket ships program. It's starting off up here, showing itself if it's hidden. We're never hiding it, that's fine. Then it's gliding 1 second down here close to the scratch cat. It's waiting 2 seconds for the beam to get sent out and the scratch cat to glide up. And then it's gliding away. It's flying off. Okay, that's the rocket ships program. The scratch cats program is make sure you're shown at the start and down here at the bottom of the screen. And then wait a second for the rocket ship to get into place and the beam to get sent out. And then take 2 seconds to glide up into that beam. Then hide yourself because you just got abducted. Okay? And then finally, the beams program, start out hidden, make sure you're in the right spot, become transparent, wait for the rocket ship to glide down. That takes 1 second. Then show yourself. It's going to take 2 seconds for the cat to glide up, so wait those 2 seconds. Then your job is done. You can go away. Hide. So those are the 3 programs. There's a lot going on there. Any questions about any of that? So I'm going to give you some time to play now. We good? So first of all, I'm going to save this. Give it to you later. And I can leave this on any slide that you want. But here is, let's see here. How do I want to do this? I have a question for you guys to try in peer instruction groups. So please get together, say hi to your neighbors, and please recreate this example, but change it slightly so that you understand what's going on. So get it working how I did it first, and then make it so that the scratch cat maybe gets away safely, like he runs away, something new, something different. And I'll give you all this code right here. So here's the scratch cats program. I'll give you all this on the slide. Scratch cats program. Here's the rocket ships program. And you can kind of see in the screenshot. There's a tiny picture of a rocket ship there, if you forget which program's which. And then finally the beams program. So there's all that if you want it. Make sure you got it working, and then try and change it a little bit. I'll give you several minutes to give that a try, and I'll play around with it, because that's how we learn. All right, so take a while, hang out, and make something cool, and then we'll come back together, and I'll talk about your first programming assignment. What's that? Yeah. Help each other. I'll give you like 7 or 8 minutes to do this. Do anybody have a question? Is there a question once upon a time? Shout out to me if you have any, but be free to do something. Maybe you can have the scratch cat send out its own beam and abduct the rocket ship. What's that? I can't hear you very well. Did you already do what I did? Have him scream obscenities at the rocket ship, whatever you want. This is good practice. I think you understand now. You got to do all these things in a certain order for it to look right and work together properly. Take like 3 more minutes. Do something as cool as you can do. Do yell at me if you have any questions about something. Alright, that was my timer. I hope that you made something cool. Feel free to save it and continue with it, or you can leave it open and continue with it after I have finished saying more things, but I want to move on just briefly in the last few minutes to talk about your first programming assignment. So I gave you your first essay last time. Now I'm going to give you your first programming assignment. Let's talk about it. So this, let's see here. This will be due, when am I doing this? August 24th, August 17th. I believe that I did the wrong date because there was a holiday last semester. It is still week 2, so let me edit the name before I confuse everybody. It's due next week, okay? Programming assignment 0, because we start our numbers and counting at 0 in computer science. But here is your first programming assignment. So again, like I was saying last time on Monday, I have 2 separate assignments for people at the start of this class. I have one for those of you who have never programmed before and one for those of you who have programmed before, because the one for people who have not is probably going to bore you a little bit because you know what's going on already. That is okay, and I have planned for that. All right. So if you have never programmed before, I promise it's not going to bore you. It's going to be cool. It is called Hour of Code. I would like you to do something at this hourofcode.com website. You can pick any of the activities. Whatever one looks the most fun for you. If you've never programmed before, go here. I guess it'll look like this for you. Pick whatever one you like. There's a couple Minecraft ones. You can make different games, but it's all going to be Scratch-like programs that'll teach you how to make a cool one, and it'll give you a little certificate of completion or something like that at the end. And so to just prove to me that you did it, just upload a screenshot or something like that as proof that you did this Hour of Code assignment, and then I'll give you credit for it. All right, so that's going to be your assignment. If you have never programmed before, go to this website, pick one of these, whatever one you want, and do it, and upload that you did it. Any questions about that one? If you have taken a computer science class or you've done a lot of programming on your own before, I have a default assignment for you if you would like to do it, if you don't want to think about a different one. This is what I'd like you to do. I am forcing you to learn a brand new programming language called Racket that is a bit weird, and it will melt your mind a little bit. That's the whole point. So this is a book. You can click on it and go through chapters 1.1 and 1.2. I'm trying to give you something that's going to take the same amount of time as the other students. So this is section 1, chapter 1, sections 1.1 and 1.2. It's going to teach you a weird little language that only uses parentheses, and it uses them in a very odd way. It's going to be very cool. It's called Racket. And your assignment is to install the Dr. Racket program that lets you have access to the Racket programming language, and you can go and do exercise 2. Okay, so do this one and just give me a screenshot showing me that you got the right answer. All right, so that's the exercise. Not too hard, I think. So that would be your assignment if you have programmed before. Okay, if you would like to do something else, if you've programmed before and you would like to do some custom programming assignment that you would like to do better than this one, just let me know and we'll find something for you that we can agree on. My only requirement is that you learn something completely new. Okay, so that is the idea, something you never learned before. So those are your 2 options. If you have programmed before, do this. If you have not, do the Hour of Code. Any questions about that? So that will be due, I think Tuesdays are my essay due dates. It's a day that we don't have class, right? And then Thursday, I think, is the 17th. Let me double check that. Yeah, the 17th, so next Thursday. This would be due. All right, so that's your first programming assignment. Yay. And so I think that is everything that I wanted to say and record. That's the end of the slides, yes.